Good evening, everyone. As you guys all start to join here, my name is Matt. I work in the admissions office at Rose-Hulman. So we've got Dr. JP Meller with us from the Computer Science and Software Engineering Department, who's going to be here to answer your questions for about the next 30 minutes. So just a couple of things, to start off with. I am going to ask that everybody stays muted throughout the presentation, the answers, that kind of stuff, just that way everybody can hear. I definitely would like you guys to put any questions you have in the chat so we can get those answered for you. But like I said, we're going to try to keep everybody muted, that way everyone can hear. So to get started here, I'm going to let Dr. Meller just talk a little bit kind of briefly about the Computer Science Software Engineering Department. Any kind of comments that you want to make would be great. And then that'll give you guys some time to start putting any questions that you have in the chat, and we will get to as many as possible. We're going to, like I said, be on here for about 30 minutes with Dr. Meller. Then we're going to have Dr. Rader from the math department jump on right at 7:30. So you guys can stick around for that as well. Okay. So Dr. Meller, the floor is yours. And like I said, I'll start trying to look through the chat and get any questions going.
Great. Good evening. My name's JP Meller. I'm the head of the Computer Science and Software Engineering Department, and we offer majors in computer science, software engineering, international computer science, and a data science second major that we run in collaboration with the math department. We've got about 475 majors majoring in computer science and software engineering across all 4 years. I think a lot of flexibility in the majors that allow you to both get a solid foundation in computer science and software engineering, as well as sort of customize your educational program by, doing either double majors or minors, a variety of combinations so that you can sort of tailor your program to your interests. So that's sort of a real quick intro to what we've got. Somebody's asking about internship opportunities. The Rose has a really great career services department, and they not only work with graduating seniors to get full-time employment, but they work with alumni as they're making, sort of career changes, and current students as they're looking for internships. And students in computer science and software engineering are blessed with lots of internship opportunities. It would be unusual that our students don't have multiple internships before they graduate. Typically that's because, maybe they have family obligations over the summer or something like that. So they're varied. We have students intern at Microsoft and Google, but also some non-traditional places. We have students intern at companies that you wouldn't think of maybe as computer science companies, things like Raytheon or Cummins. They make engines, but there's lots of microprocessors and computing software in their engines. So there's a question about the difference between computer science and international computer science. Our international computer science program is actually a dual degree with a school in Germany, Technical University Ulm, and the way that works is that there are, you can complete it from either side. So students do the first 2 years at their home institute, and then their junior year is spent in Ulm, and then the senior year is spent at Rose. And when you complete that program, you get a degree from both Rose and Ulm. So it's essentially the same requirements, or the International Computer Science program satisfies the requirements of the CS degree, but there's a little less flexibility. For example, you have to take a year of German before you leave Rose to go there, and while you're in Germany, you'll take a technical German course. So there's a few things like that where the a CS major who's not doing the international CS would have a greater choice of their humanities courses. So somebody's asking how much experience do you need before taking computer science? And we, beyond the regular admissions requirements to Rose, we don't make any assumption about prior experience in computer science. So you don't have to have had a sort of a programming course or a computer science course in high school. If you do have the opportunity to have those experiences, then we have some mechanisms to place you a little further along in the curriculum, sort of based on your level of mastery. We don't want you to repeat material that you already know. That's not good for anybody. So there's a mechanism to do that. But you don't have to have any particular experience before you come to Rose. So back to the International Computer Science, that particular degree is a arrangement that's set up specifically with Rose and the Technical University in Ulm. You can certainly do study abroad, and courses will transfer back and things like that. But that's not a dual degree program. You don't end up with a degree from that other institution. Sort of dual degree programs are pretty specialized in that they take a lot of legwork behind the scenes to make that exchange possible, so that you can get a degree from both institutions. So the International Computer Science is limited to just that university. Some questions about research opportunities. So there are a number of research opportunities. Our faculty members, sort of are active in a variety of fields. So artificial intelligence, data science, machine learning, robotics, security. Those are all topics that are lots of activity in our faculty. There are some other topics as well, but those are some good examples. And our faculty tend to work on and do professional development in those areas, and frequently involve students in the work that they're doing. And so primarily it's a matter of matching interests. So if there's a topic that you're interested in, and so seeking out that faculty member and exploring the possibilities there. We have some courses that are designed to help expose students to the research process, and to help facilitate sort of that matching up, so that there's a variety of ways to do that. Yep. There are also some students, instead of an internship, actually perform research over the summer, and there's both on the campus of Rose, but also at other institutions that may host a larger effort in a particular area. So great. What else? Let's see here. Programming languages. So variety of programming languages. So I will sort of give my standard thing. Programming languages really as a specific language really isn't the focus. So in our first course, you will use Python, and there, but even in that course, the emphasis isn't as much on the language of Python, and it's more on solving interesting problems with a computer. And there, regardless of the language that you're using, whether it's Python or Java or C, there are concepts that are common across all of those languages. So things like decisions and iteration and the notion of functions or procedures or methods, same idea, sort of slightly different words for those. How to sort of design a software solution to a problem and decompose it into small chunks, that you can actually code and sort of test and debug and verify. Those are the things that we emphasize in our courses. And then, that's transferable to any language that you might use. There may be some differences in how that language accomplishes some of those tasks. Some languages may have some special features or some special capabilities. But once you've learned one programming language well, it's pretty straightforward to pick up other programming languages. And so, real beyond our first course or beyond the first few weeks of our second course, there's really not a lot of emphasis on the particular language. So having said that, our first course, I already mentioned, is in Python. Our second course is in Java and really focuses on object-oriented design. So that's sort of a change there. In other courses in our curriculum, you'll see Scheme, assembly language, C, you'll see SQL, you'll see, sort of some JavaScript, and then depending on which specific courses you take beyond that, electives and things like that, then you may see a variety, sort of other languages, perhaps C#, maybe Ruby. There's it sort of depends on what you end up doing there. So the computer science and software engineering department does not have a master's program. So, but you can do, for example, get a bachelor's degree in either computer science or software engineering and a master's in engineering management. And so you can take advantage of the, sort of the, sort of 3+1, 4+1, and do a master's. But the master's level degree won't be in computer science or software engineering because our department does not offer that. So physics courses. So the computer science major requires physics 1 and 2, and chemistry 1, and then a 4th term of science, and that could be, basically any science course. So you could do a 2nd term of chemistry, you could do a 3rd term of physics, you could do some biology. So lots of variety there on how to do that. Let's see. Yeah, so interdisciplinary, options. So I mentioned the data science. Second major is sort of jointly run with the math department. That's sort of an example there. The computer science software engineering department's one of the key contributors to the robotics minor, which is a collaboration between our department, electrical and computer engineering and mechanical engineering departments. And so those, so that's another example of a multidisciplinary, sort of opportunity. We have a number of faculty in our department that have joint appointments, that have, they're in our department, but have expertise in mechanical engineering, biology, for example, and commonly teach courses in those other areas as well. So there's lots of opportunity there, for interdisciplinary activities. One vehicle for that is to do minors or second majors. Another is to just take, so the computer science major has a number of, sort of free electives and tech electives that you need to take. So a total of 6, sort of electives that you can, sort of choose basically from anywhere. And so you can use those to sort of there's even more electives depending on how you count them, but those are the least restricted electives. So you can certainly use those to take, to go towards a minor or a second major, or depending, maybe there isn't a minor that exactly fits what you're looking for, but you can put together a collection of courses around your interest and use those electives to meet that goal. Great. So one of the questions is about difference between computer science and computer engineering. I'm going to kind of expand that slightly and talk about the difference between computer science, computer engineering, and software engineering. And I'll start with the software engineering, and sort of as a pretty succinct definition, I would define software engineering as the process of engineering a software solution for a specific client's needs. So that's sort of the kind of a vision statement for software engineering. And so that's going to involve things like being able to manage the project, deliver it on time and on budget, being able to know what the requirements are for the project. So some requirements engineering to be able to have some quality assurance, being able to test and verify that the piece of software that you built actually solves the problem that you set out to do. It's sort of not just, well, I think it does, but in a principled way, be able to test and deliver that, and have some eye towards that there's a reasonable design and architecture for that piece of software so that it's maintainable into the future, that there's a whole life cycle for that software. So those are some of the things that the software engineers really focus on. Computer science, I would, is sort of, we would define that as just the study of computation. Now that seems pretty broad. Some of the questions that are key for computer science is what kinds of problems can you solve with a computer and how efficiently can you do that? But that might sound a little theoretical, and there definitely is some theory there that's important, not real helpful to try and solve problems that can't be solved with a computer. So, but we value, hands-on and actually applying the theory that you learn. So, at the end of the day, you've got to implement a computing system. You got to have, the whole package. So some of what you understand, part of what computer science helps you do is decide what things should go in the hardware, what should go in the microprocessor, what should go in to operating systems or device drivers, what should go into programming languages or libraries, or what kinds of things should go into user applications, things like that, so that we have a computing system that's useful to folks and works efficiently and does good stuff out there. So computer science really focuses on that, computing as a whole. How does it work, and how do we use it effectively? And so then back to the computer engineering, I would basically say computer engineering is an analogous definition as software engineering, except just substitute hardware for software. So that computer engineering is engineering a hardware solution for a specific client's needs. And so some of the same challenges or concerns are important to computer engineers that are for software engineers. Doesn't mean that those concerns aren't, that computer scientists don't need to know anything about those concerns. That's just not one of the key focuses for them. Some of the differences, I think, from computer science programs at other universities. There's a wide range of computer science programs out there. Some places computer science is, sort of grouped with math. They're in schools of science. There are even some computer science programs that are in business schools. We treat computer science very much as an engineering discipline, and we think it is. It's a little bit, the computer scientists maybe aren't focused on delivering a specific solution for a particular client, but nonetheless, building a computer system and understanding the trade-offs of where, sort of you put different functionality to have a useful computer system is very much an engineering thing. And so for us, it's very hands-on in that, for example, like we have a computer architecture course where you learn a bit about, sort of how the hardware in your computer gets the work done. And the final project in that course is to build your own microprocessor. So it's not just, hey, let's learn a few things about how this works. You actually get to dig in and do it. So let's see. Specific areas in computer science that students can focus on. So I mentioned a number of the areas that our faculty are interested in research, and we have a lot of electives that line up with that. So ranging, we offer a number of courses in computer security, artificial intelligence, computer vision, machine learning. So there's a wide range of electives there. Probably too numerous to list right here. I don't think I could remember them all, but a wide range of electives. Data science and computational mathematics. Well, I'm not exactly sure what computational mathematics is. Data science really focuses, looking at data and trying to learn from, make inferences from that data. Sort of learn patterns. So artificial intelligence and machine learning are important parts of that. Statistics is an important part of that data science. So then those are, things there. You could certainly combine, though the data science is a second major at Rose, so that you have to have something else as your primary major. Right now, computer science, software engineering, and mathematics are the most common, but that doesn't have to be the case. We think data science is applicable to other disciplines, mechanical engineering or even chemical engineering. So that is also certainly possible.
Hey, Dr. Miller, sorry to interrupt you. We've got just a few minutes left here. I wanted to also real quickly welcome Dr. Rader and Dr. Reyes in as well. We'll get started with math in just a few minutes, but wanted to see if maybe you could talk kind of a little bit here towards the end. I know there was a question or two kind of about the, I think, advising process, and then maybe a little bit about what the students are doing, if you know any specific internships that they're getting, or maybe even just talk about the companies, specific companies that we have some good connections with, that kind of stuff, just to kind of to finish up here for the last few minutes.
Sure. So advising, I mean, I think academic advising is as much as we can handled in the department. Our colleagues in math help out during our first year. The number of majors has risen over the last few years, and so they have graciously offered to help us with that advising. But each student has an academic advisor that helps chart their their academic course, and answer questions about sort of prereqs and helps them make choices for electives. So that's somebody that you can bounce ideas off, or get help picking courses based off your educational goals. And then I think the other question had to do with internships, like what kinds of companies have folks gone to. Our students go lots of places. We've had a number of students go to Microsoft over the years. We've had students go to Google, Amazon, Groupon, a lot of the West Coast tech. There's a growing sort of software engineering community around the Austin area. So there's a number of companies in the Austin area doing things such as software consulting or big data, Hadoop type things. We've sent students to those companies. There's another sort of hub of software engineering work actually in Indianapolis, and we've sent a number of folks to internships in the Indy area. Those are sort of some of the larger clumps, but really they go all over. We have a career fair in the fall. It's typical, somewhere between 400 and 500 companies come. It's every year for as long as I can remember. There are more companies looking for, CS or SE students to hire than there are graduates in our senior class. That's individual companies. Some of those companies are looking for more than one person. Well, it's similar on the internship side. We don't have quite as much information about the number of interns that they're looking for, but there's lots of opportunity there, and lots of choices to pick amongst. So if you have a particular field that you're interested in, or a particular area of the country, there's some likelihood that you have some choice that might match up with that.
Awesome.
So, great.
Yeah, that was very quick 30 minutes, right? I know we had a lot of questions in there. So I want to thank Dr. Meller for joining us. We are going to move on to math here in just a minute or two. But if you don't mind putting your email maybe in the chat, that
Sure.
way anybody that has any questions, feel free to reach out to Dr. Meller, and he will get you the answers. Like I said, I appreciate everybody with all the questions that you submitted. I know there were a lot that we weren't able to get to in this kind of short time, but I know that the department would be happy to answer those for you. So